Here we go, and welcome to Lesson 8 of the Earth topic. Please remember to complete the Show My Homework quiz after this lesson, which you can find by clicking on the Show My Homework entry for Lesson 8 of the Year 7 Science Earth topic. Here's a quick starter before we get going. The chemical formulas are on the left-hand side. You don't have to write this down, just think to yourself, for each chemical formula, what's its name? What are the atoms? How many of each type of atom? And then think to yourself, what is the definition of a chemical formula? Pause the video, think or discuss your answers. Pause it now. Here we go. Let's have a look through each of these chemicals. H2O is water made of hydrogen and oxygen atoms. There are 2 hydrogen atoms for every 1 oxygen atom. So a small group of atoms like this is called a molecule. Inside the molecule, 2 hydrogen atoms for every 1 oxygen atoms. Oxygen has the formula O2 because there are 2 oxygen atoms bonded together inside each molecule. Remember, a chemical will be made of millions and millions of molecules, but in every molecule of oxygen, there are 2 oxygen atoms bonded together, hence the formula O2. Carbon dioxide is made of carbon and oxygen atoms. There is 1 carbon bonded to 2 oxygen atoms inside every molecule. Methane is CH4 because there is 1 carbon atom bonded to 4 hydrogen atoms inside every molecule. Nitrogen is N2 because in every molecule there are 2 nitrogen atoms bonded together. Argon has the symbol Ar, is made of single atoms that aren't bonded to any others. Please remember, a chemical will always be made of millions and millions, if not billions, of particles. But in these chemicals, these are liquids and gases, every particle contains a small group of atoms bonded together, and the chemical formula, the definition of a chemical formula is that it tells us the types of atoms in a chemical, but also how many of each type there are. It is relative to each other. In carbon dioxide, there'll be 1 carbon for every 2 oxygens. There will be millions of particles, millions of atoms, but 1 carbon for every 2 oxygens. Okay, now we've been learning about how the Earth gives us natural resources, which we can then use to we can use chemistry to change them into useful products. We've seen how crude oil gives us a range of fuels like petrol and diesel, how natural gas gives us methane, but how dangerous is burning a fuel? What are the environmental impacts of burning a fuel? We're going to start looking at that by learning about combustion reactions. Right, now, do all fuels burn the same? And what do we mean by combustion reaction? Well, a combustion reaction is when a fuel is burnt to release the energy in the fuel. Okay, these are all exothermic reactions. Heat energy is being given out. The energy comes from inside the fuel. So a combustion reaction is when a fuel is burnt to release the energy that was stored in the fuel. Okay, now they don't all burn the same. Motor oil is surprisingly difficult to light on fire. Diesel, that is, surprisingly difficult to light on fire. The others light on fire very easily. You can see them burning with a yellow flame here. When the motor oil or diesel eventually catches fire, you can see some sort of smoke coming off there first, and then it burns with a more sort of dark, sooty flame. Let's have a look at another fuel burning. This is ethanol inside what we sometimes call a whoosh bottle. It's just an empty plastic container. It's got ethanol inside it. And does this burn with a yellow flame? Let's have a look. Right, there we go. It's burning with a blue flame. There's no soot being given off, and it's burning with a clear blue flame. So that was ethanol. So fuels do always give out energy when they're burnt. The energy from the fuel is released when they are burnt, but they don't all burn in quite the same way. Some give off more soot, some have a yellow flame, some have a blue flame. But keyword, combustion. Burning a fuel is called combustion. Combustion releases the energy which was stored in the fuel. Okay, before we go any further, what is a combustion reaction? Pause the video and choose the correct definition. Is it A, B, C, or D? Pause it now. Here comes the answer. The correct answer, let's read it through, is not that one. It's not about splitting a hydrocarbon. Where fuel reacts with oxygen to release energy, yes, that does happen. Where petrol burns to make a car move, we need more science detail than that. Reaction where fuel reacts with oxygen to take in energy, no, it's giving out energy. The correct answer is B. A fuel reacts with oxygen to release energy. So you do have to burn the fuel, and that does require oxygen. but the energy from the fuel does get released. Right, what is oxidation? Quick revision. Is it just combustion reactions, or is it any reaction with oxygen atoms? What do you think? A or B? Make your choice now. Okay, here we go. Oxidation is any reaction with oxygen atoms. Okay, now combustion does involve oxygen, but there are other reactions with oxygen that are also called oxidation. So oxidation is a big group of reactions, anything where oxygen is reacting. Combustion is more specifically when a fuel reacts with oxygen to release the energy of the fuel. Okay, here's a tricky question. So what is the difference in the meaning of oxidation and combustion? Pause the video, think of an answer. If there's somebody in the room, try and discuss it with them. What do you think? What do they think? But if not, think to yourself, what is the difference in the meaning of these two keywords, oxidation and combustion? Pause it now. Let's have a look at my answer. I said, oxidation is any reaction where a chemical reacts with oxygen. Combustion is where a fuel is burned to release energy. It does need oxygen to make it burn, so actually combustions are normally oxidations as well. So if a fuel burns and releases energy by reacting with oxygen, it can be combustion and oxidation at the same time, right? So oxidation is any reaction with oxygen. Combustion is when a fuel burns to release the energy in the fuel, but it does need oxygen to make it burn. Now, all the fuels we've learned about in this topic, like methane or petrol or diesel, are hydrocarbons. Methane comes from natural gas. Petrol and diesel and kerosene and fuel oil come from crude oil. But they are all examples of hydrocarbons. Remember, a hydrocarbon is made of hydrogen atoms and carbon atoms. Therefore, when they are burnt, when they react with oxygen, they will produce carbon dioxide and water. So this is both an oxidation and a combustion. It has to react with oxygen to make the fuel burn. Fuel is burning and releasing energy, so it is a combustion reaction. So hydrocarbon reacts with oxygen to produce carbon dioxide and water. Remember, the carbon atoms join with oxygen to make carbon dioxide. The hydrogen atoms join with oxygen to make H2O, water. Now, a consequence of this is carbon dioxide is a greenhouse gas. It causes the Earth's temperature to rise. We're going to learn a lot more about that in lesson 9. Okay. Now, this is one of the downsides of using hydrocarbon fuels. They give us energy from their fuels, but they also produce carbon dioxide, which is a greenhouse gas. It causes global warming and it causes climate change. So that is a big negative of using hydrocarbon fuels. The carbon in the hydrocarbon reacts to form carbon dioxide, which causes global warming and climate change. Okay. Now, there's an extra term for this. We call it complete combustion. If a hydrocarbon burns and it makes carbon dioxide and water, we use this extra term. We call it complete combustion. Now, that's because there is also something called incomplete combustion, which we'll look at in a moment. Complete combustion happens when there is plenty of oxygen. So if a hydrocarbon burns to release its energy with plenty of oxygen, it will make carbon dioxide and water, and we call it complete combustion. But if there's not enough oxygen to completely react to the fuel, then something happens called incomplete combustion. Okay, so if there's less oxygen, not enough to completely react the fuel, then what happens is something called incomplete combustion. Now, in incomplete combustion, the carbon joins together with one oxygen to make CO. That's called carbon monoxide. Okay, so if there's not enough oxygen to make CO2, it makes CO instead, carbon monoxide. Now that's a problem. We'll get to that in a moment. But we call this incomplete combustion. So if there's less oxygen, not enough oxygen for complete combustion, it does incomplete combustion instead. The fuel still burns, but because there's less oxygen, it makes carbon monoxide and water instead. Now, carbon monoxide is dangerous. It is a poisonous, toxic gas. It can suffocate. It can even end people's lives. Okay. Now, for that reason, it is important to have carbon monoxide alarms. We use hydrocarbon fuels in our central heating, in ovens, in cookers. If they were to malfunction and go wrong, then you could get incomplete combustion, and that could create carbon monoxide. All new homes in Britain are required to have a carbon monoxide alarm. Some older homes don't have them, but you can buy them literally in supermarkets for about £20–25. Some people find that difficult to afford. Other people feel like they can afford it. Sometimes it's worth checking at home. Do we have a carbon monoxide alarm? Because if there was a fault, it's hard to detect. You can't smell it. You can't see it. When the alarm, if you ever get a carbon monoxide alarm going off, then tell somebody at home to phone, the gas engineers, whoever supplies your gas, because that means there's a fault and that needs fixing. Carbon monoxide, CO, is toxic, poisonous. It is dangerous. So carbon monoxide alarms are important. Right. Now, we have two types of combustion. Remember, combustion is when a fuel burns to release energy. But if that happens with plenty of oxygen, then it makes carbon dioxide and water, producing CO2. That's a problem because it causes global warming. If there's not enough oxygen, incomplete combustion happens. That makes carbon monoxide and water. Carbon monoxide is CO. That's also a problem because carbon monoxide is a toxic, dangerous gas. So both combustions cause problems, and this is the downside of using hydrocarbon fuels. Now, can we practice which one is which? For each of these questions, think to yourself, is it complete or incomplete? Let the video play, there'll be one at a time, and for each one, say to yourself, is it complete or incomplete? Not enough oxygen. Which one is that? Incomplete. Plenty of oxygen. That's right, it's complete combustion. Makes CO2. Complete combustion. Makes CO. Yep, you've got it. It's incomplete combustion. Makes CO. Carbon monoxide. Makes a toxic gas. Incomplete combustion makes carbon monoxide, toxic gas. Causes global warming. That's right, it is complete combustion, which makes CO2, which causes global warming. Which one produces carbon dioxide plus water as the products? Complete combustion produces carbon dioxide and water. Which one produces carbon monoxide and water? Yep, you got it. It's incomplete combustion, produces carbon monoxide and water. Okay, now we need to be clear about the difference between the two. And this is going to be part of the writing task in a minute. So take a look and try and remember these facts. What is the difference between complete combustion and incomplete combustion? Now, just to put some extension into this, looking at chemical formula. Here is the chemical formula of carbon dioxide, carbon monoxide, and carbon. Now, if a flame produces soot, if it's a yellow flame or if it's got black bits in it, that is soot being produced, and the soot is made of carbon. Right, now it needs plenty of oxygen to make CO2. Look at the formula. CO2 has got more oxygen in it. Carbon monoxide's only got one oxygen in the formula. Carbon, soot, has got 0 oxygens in the formula. So the less oxygen is available, the more likely it is to form carbon monoxide or carbon. And we can see that from the differences in their chemical formula. If there's not enough oxygen, carbon dioxide cannot be formed. These other chemicals will be made instead. Their formula contains less oxygen atoms. But carbon monoxide, mono refers to one. There's one oxygen for every one carbon. Di in dioxide refers to two. There are two oxygens for every one carbon. Now with carbon soot, that is another problem. It pollutes the air. It causes breathing difficulties. Not a good thing. It's a bad thing if carbon soot is being produced. And just to focus on the names, dioxide means 2 oxygens for every carbon. Monoxide, mono equals 1 carbon for every oxygen. And then carbon, soot, there's no oxygen. It's just pure carbon being given off in the form of soot. So that is another potential product of incomplete combustion. So just to match them to their problems, CO2 causes global warming and climate change. CO is a poisonous toxic gas. And carbon, soot, causes air pollution and breathing difficulties. And carbon soot All carbon monoxide can be made by incomplete combustion. CO2, carbon dioxide, needs plenty of oxygen. That's what we call complete combustion when CO2 is made. Right, okay. Quick quiz before we do the writing task. True or false? Pause the video and go through each question. Is it true or false? 10 questions, T or F. Think your answers, true or false. Pause it now and press play again when you've thought of your answers. Here we go. Let's see if you were right. Complete combustion needs plenty of oxygen. True. Combustion is a type of oxidation reaction. True. It needs oxygen to make it react. Incomplete combustion makes carbon dioxide. No. False. Incomplete combustion can sometimes produce carbon monoxide or soot. True. Incomplete combustion produces water. Yes, it does. Carbon monoxide plus water is made. True. 6. Complete combustion. Yeah, that's true. Makes carbon dioxide and water. 7. Carbon is a poisonous toxic gas. No, that's carbon monoxide. So 7 is false. 8 is true. 9 is true. And 10 is true. Okay, hope you got on okay with that. There's a lot of detail to this complete and incomplete combustion business. Right. A little bit of practice before we do the writing task. What does the word combustion mean in science? Apologies for the typo there. What does the word combustion on its own? So don't worry about complete or incomplete for this question. Just the word combustion. What does it mean? Pause it now. Okay, on its own, the word combustion means when a fuel burns to release energy. Right, so combustion is when a fuel is burnt to release its energy, and it burns by reacting with oxygen. Okay, it is finally time for the writing task of this lesson. What does combustion mean when just the word combustion is on its own? What is the difference? What's the main difference between complete and incomplete? And then more detail in the differences between complete and incomplete. So here's some sentence starters to help you. What is combustion? What does the word combustion mean on its own? What's the main difference between complete and incomplete? Then for yellow, going into more detail about complete and incomplete. What are the environmental problems? Which chemicals are made? And then the extension to link that into the chemical formula and the differences in the atoms in the chemical formula. Pause the video, take as long as you need to use these sentence starters to help you summarize the differences between complete and incomplete combustion. Pause it now. Okay, I'm going to move this along to the answers. Okay, here we go. So please do remember to tick your work and feel good about all of the signs that you are getting correct. And please do use the answers to add anything in that you didn't think of. Here we go. Combustion is when a fuel is burnt to release the energy stored in the fuel. Oxygen is needed for the reaction. Okay, so combustion is when a fuel is burnt to release energy. Complete combustion happens when a hydrocarbon burns in plenty of oxygen to make carbon dioxide and water. Incomplete combustion happens when there's not enough oxygen, so it burns to make carbon monoxide and water instead. So if you're getting the idea of plenty of oxygen forms carbon dioxide and water, not enough oxygen makes carbon monoxide and water, then that is the correct understanding. If you haven't used the word hydrocarbon, then do add that into your answer, because it is the hydrocarbon burning which forms carbon dioxide and water, or carbon monoxide and water if there's not enough oxygen. Let's look in more detail at these differences. The main environmental problem caused by complete combustion is global warming and climate change. This happens because it produces carbon dioxide, which is a greenhouse gas. The environmental problems caused by incomplete combustion are it produces a poisonous toxic gas. It also produces soot, which causes breathing difficulties. These happen because incomplete combustion produces carbon monoxide, that's the poisonous toxic gas. Incomplete combustion can also produce soot, carbon, which causes breathing difficulties. So the idea here is to go into more detail about summarizing the differences between complete combustion and incomplete combustion. Complete combustion producing carbon dioxide and water. Carbon dioxide is a greenhouse gas causing global warming. Incomplete combustion producing carbon monoxide, a toxic gas, or carbon soot, which causes breathing difficulties. Remember that incomplete combustion will also produce water, carbon monoxide plus water. Okay, right, using chemical formula to explain what's happening. These different chemical formula can be produced in combustion reactions because if there's plenty of oxygen, carbon can join with two oxygen atoms to form CO2. But if there's not enough oxygen, one oxygen atom joins with carbon to form carbon monoxide, CO. Or if there's not enough oxygen for that, carbon C will be formed because if carbon doesn't join with any oxygen atoms. Water is always formed because it's a hydrocarbon that's burning. A hydrocarbon, as well as carbon, contains hydrogen atoms. The hydrogen atoms will join together with some of the oxygen to make H2O, water. So incomplete combustion will still make water H2O when the hydrogen atoms of the hydrocarbon react with oxygen. Okay, today I achieved describe because I can describe the general meaning of combustion. Today I achieved explain because I get the main difference between complete and incomplete combustion. Today I achieved use because I can summarize different products and environmental problems of complete and incomplete combustion. And today I achieved combine because I can explain the difference between how carbon dioxide, carbon monoxide, soot and water are formed by looking at the atoms and the chemical formula. Well done for your work today. Not an easy lesson. We will go into more detail about complete and incomplete combustion at GCSE by looking at word equations and chemical formula. But for today, hopefully you'll have the main idea of the environmental problems caused by complete and incomplete combustion because of carbon dioxide and because of carbon monoxide. Well done for your effort today. If you're putting in a really good effort to trying to do your best on this written works, then that is fantastic. And please do feel proud of your effort. Show somebody your work so that they can feel proud of you too. Please remember to go back to Show My Homework and try the 10-question quiz. Click on the Show My Homework entry for Lesson 8 of the Science Earth topic and complete the 10-question quiz about complete and incomplete combustion. Well done for your work today. Good job, Year 7. Well done. You're doing really well. Keep it going. See you next time.